Welcome. In this lecture, we will look at some numerical problems and solve them. These numericals are from GATE Chemical Engineering paper. GATE Chemical Engineering paper related to the dynamics of first order systems. Well, the first question is this. This is from 2009 Chemical Engineering paper. Question number 44 in that. If you have question paper, you can have a look at it. The question goes like this: for a tank of cross-sectional area 100 square centimeter and inlet flow rate QI, this is QI, this is QI in cc per second. The outlet flow rate is Q naught, this is Q naught, here Q naught. Is related to the liquid height H. Liquid height is shown as H as Q naught. This Q naught equal to 3 into root of H. See figure below. So in the figure also it is given the same Q naught equal to 3 into root H. Now you are required to find out the transfer function Hs by QIS. The overbar indicates, overbar is this, it indicates deviation variables. Transfer function of the process around the steady state value QIS, around the steady state point. What is the steady state point? QIS equal to 18 centimeters cube per second and Hs 36 centimeter. That is at steady state Hs is 36 and QIS inlet flow rate is 18 centimeter cube per second. So you have to find out the transfer function and see which one of this is the correct transfer function for this system. So this is a tank with where liquid is flowing through the tank, and if you see the flow head relationship is given by a nonlinear relation, right? Q naught is proportional to H. So for this, what will be the transfer function? This transfer function also will be a first order. We have discussed this in my lecture, which was titled as PC52. Lecture titled as PC52. We have discussed this process, this tank with the flow head relationship of this form, and we found what did we find there? What is the transfer function? If I had gone through that PC52, anyway, the link is available below. If I had gone through that, you would have noticed that, you will remember that the transfer function, what they had asked h bar by QAS. Okay, I had used here Hs by QS. So Hs, this is what they had asked is H bar by QI bar S. H bar by QI bar S. QI is the inlet flow rate. That's all. It's a different symbol. That's all. GATE papers, different papers may have different symbols for the same type of problems. So I had used in my lecture Q and H. Here they had used QI. That's all. So H by QI will be K by tau S plus 1. And in my lecture, the capital letters directly represent the deviation variables. In my lecture PC52, the capital letters, uppercase, directly represent the deviation variables. Here, the deviation variables, the capital letters alone do not represent the deviation variables. The capital letters here are the actual variables. Deviation variables are denoted by overbar. Are denoted by this overbar. That's all. So there will be difference of notations. Okay, so we found that as K by tau S plus 1, and K, it is equal to R1 and tau equal to AR1 and R1 equal to 2 into root of Hs by C, right? The question seems to be very big, but let's see the solution. The solution is also big. Simple, we need this, that's all. So let us evaluate what is R1. So R1 equal to 2 into HS by C. So in this case, he has used capital H only. So he has used capital HS. Okay. This HS he has used as capital HS. Doesn't matter. So we'll use small h's. Only value only matters for us. So HS is how much? What is the steady state height? The steady state height is given here as given here as 36 centimeter. 36 centimeter, right? So HS is 36. Root of that by C. C is given as 3, I think. So this is C. Here C is 3. C into root H. C is 3 here. C is 3 here, right? The constant, proportionality constant. So by C is 3. So what is the answer for this? Equal to 4. So R1 is 4. And therefore tau equal to area is given as 100 centimeter square. All the given units are consistent. Centimeter square here and centimeter cube and second. So area is 100 centimeter square. So area is given as 100 centimeter square. So tau equal to A into R1. 100 into 4. 400. So now you can find out, you can tell me, you can easily say what is the transfer function. What is the transfer function? K by tau s plus 1. K is R1. Okay, K is R1. So K is R1. K is, so the required transfer function is K. K is 4 by tau is 400 S plus 1. So this is the answer. So H, whatever is asked, H bar S by QIS equal to 4 by 400 S plus 1. R, K, the gain. K is the resistance, not resistance, modified value of resistance. R1 is 4. Tau is A into R1, 400. 4 into 100, 400. So this is the transfer function. What they say, is there an option for this? Yes, 4 by 400 plus 1 is option D. This is option D here. Option D here. Okay. So answer is option D. Option D. So the question looks very big. Question looks very big, but solution is very simple. If you know the equations, if you understand the concept, if you understand where this theory relates, where this related theory comes to, where you studied this related theory, and from the related theory, what is the formula required for this transfer function? What is the transfer function formula related for this transfer function? Where you have to look for it? What is the formula for that, and how do you estimate that? If you know that, the solution is very simple. How many steps you did? Of course, this is the first formula you should know. Then you have step 1, evaluate R1, then evaluate tau. That's all. Once you evaluate R1 and tau, 2 simple steps. And third step, you get the answer. Right? Very simple question. Question appears to be big, but solution is very simple. So you have a similar equation in another GATE paper subsequent years. So let's have a look at this question. This is from Chemical Engineering GATE paper 2023, question number 25. So you can have a look, you can go through this question. A liquid surge tank has F in and F out. F in and F out as inlet and outlet flow rates respectively, as shown in the figure below. F out is proportional to the square root of the liquid level H. This is the liquid level H. The F out is proportional to this. The cross-sectional area of the tank is given 20 centimeters square. Density of the liquid is constant everywhere in the system. So at steady state, the flow rates are both flow rates equal, being equal to 10 centimeters cube, 10 centimeter cube per second, and steady state height is 16 centimeter. The variation of h with f in is approximated as first order transfer function. So this related to this is approximated as a first order transfer function. Which one of the following is the correct value of the time constant of the system in seconds? So 4 values are given, A, B, C, D, which is the correct time constant of the tank system. So this is again tank, and what is the flow head relationship here? So this is the flow head relationship. F out is proportional to the square root of the liquid level. So this is the flow head relationship. So you would understand that this question is exactly similar to what we had discussed this. So I hope you can solve this. Once you know this, once you have gone through this PC52 and once you solve this equation, previous one, this one, you can easily solve this. Here not even transfer function, only the time constant is asked. The only thing, see here, the various notations are different. They need not use the same notation for all the time. So here notations are Qi and Q naught. Here they are given as F in and F out. So you have to read the, and where is the, how do you know it is flow, what is the flow head relationship? You have to read the question. So you have to read the question fully, whether the question is big or small. You have to read every word, every sentence, every word of the question. Then only you should try to solve the problem. Once you have read the full question and once you understand what is the theory behind that, what are the equations, the solution will be hardly 2 or 3 steps. Well, solve this problem. This is also from GATE. This is exactly the same as the previous question we solved. Both these questions are similar. So you should be able to find out the time constant as you had found out here. As I found out time constant here, the same way you find time constant here. And you can leave your answer in the comment section. If you have any questions, then also you can leave on the comment section. See you till my next lecture. Bye.